Welcome, ladies and gentlemen. What I'd like to do is kind of go over a summary of solving two-step equations. So congratulations, first of all, for making it this far in the course. And what I'd like to do is just go through kind of the process again of first solving two-step equations, as well as then kind of highlight on some tips and tricks that I found as a teacher and teaching in the classroom, as well as some common mistakes that I see from myself, as well as from some other from students. So first of all, to kind of go through a two-step equation, basically we're going to have two operations that are happening to the variable. So we want to isolate the variable, get the variable by itself. So to do that, we want to make sure we locate the variable and then locate the two operations that are happening to the variable. We want to make sure we always undo addition and subtraction first, and then undo multiplication and division. And when we undo them by using our inverse operations as well as using the properties of equality. So if I'm going to undo addition, I need to make sure I subtract on both sides of the equal sign. When I undo division, I need to make sure I multiply on both sides of the equation. And then once I get my final solution, I can always check it by plugging it back in to make sure that when we have the end, we want to have our variable by itself equal to a value. So let's kind of hit in some tips and tricks. When I have 3x plus 7 equals 19, again, one of the common tricks I said, even for one-step equations, is to circle the variable. A lot of times when I circle the variable, it just kind of visually allows me to say, all right, here's what I want to get by itself. I'm kind of like pinning this to the paper or to the board and saying, I'm not going to move this, but what do I need to do to get rid of the 3 and the 7? Well, the 7's being added, so I undo the 7 on both sides. 3 is multiplying by x, so I'm going to undo the multiplying by dividing on 3 on both sides. Rewrite the variable to the left, and this is a big one. I get this mistake a lot. Students usually don't have a problem with an equation like this. They see what's happening to the variable very easily. However, all it takes is a couple subtraction signs, and I can mess up students very, very well with this. So you can look at this and say, oh, OK, now what's happening to the variable? Well, now my variable, it's being added by 7. You might say, well, there's no addition sign. Well, there's only a subtraction sign. I understand you can only see the subtraction sign, but that's saying 7 minus 3x. It's not saying 3x minus 7. So what I like to do is rewrite it with the variable to the left. So this is a negative 3x. So I got to rewrite that first. And then this, there's no negative symbol in front, so that is a positive 7. All right, now you can see, oh, my variable is being added by 7, so I subtract 7. And now it's being multiplied not just by a 3, but by a negative 3. Since we read from left to right, I think it's sometimes a lot helpful to apply your operation or to rewrite with your variable from the left to the right to help you not make that common mistake. And the last kind of tips and trick, this becomes very important when we get into solving multi-step equations or even quadratic equations. But even if you're a little bit hesitant or you just want to make sure you're doing everything correctly, when you get your final answer, x equals 4, I'm just writing a random answer. When you get x equals 4, plug that 4. Actually, well, I'll put it in for this one, right? So let's say we solve. So we get x equals 4. Take that 4 and plug it back into the equation. So therefore, I say 3 times 4 plus 7 equals 19. When I put 4 in for x, does that make the left side equal to the right side? Well, 3 times 4 is 12. 12 plus 7 is 19 equals 19. Ding, ding, ding. There you go. Some common mistakes. Symmetric property. And this kind of goes back again to what I was talking about with putting the variable to the left. Yeah, OK. Putting the variable to the left. Again, we know that 4 plus 3, that's equal to 3 plus 4, right? But that doesn't work, again, the same when we have subtraction. So you have to be very careful, especially when you're trying to solve an equation. And maybe let's say you have 3x minus 4 equals 10. I don't know. But when you're solving these, or let's make this positive, you got to make sure that you can't just swap them and say 4 minus 3x. That doesn't work. All right. You got to make sure if you're going to rewrite this, that it'd be like negative 4 positive 3x, because that 3x is positive, even though we'd like to write it in that format. But let's say I had it like this, right? If I want to rewrite this, that's a negative 4x. That's a positive 3. So I have to rewrite it with the correct format to be able to solve the problem. So a lot of students, they understand the symmetric property for addition, but don't make the mistake for subtraction. You got to make sure you keep the signs when you're rewriting them. The last thing is order of operations, knowing the reverse order of operations. X over 5 minus 7 equals 10. A lot of students automatically see the fractions, and they just want to get rid of the fraction now, which this one you can. You could actually multiply every single term by 5. But a lot of students will just say, oh, well, I want to get rid of the fraction, so I'll just multiply this by 5 and that by 5. And they don't multiply the 7 by 5. And the problem with that is when you're using your inverse operations and isolating it to just your variable, you've got to follow the reverse order of operations. We always want to undo addition and subtraction first, then undo multiplication and division. This would kind of be an isolated incident because as long as you multiply the whole equation by everything, you're not going to be changing the problem. You're still going to produce equivalent equations. However, that doesn't work for addition and subtraction. So you got to be careful. And I don't want to get too much off on a tangent on this. But just make sure you follow your reverse order of operations. So there you go, ladies and gentlemen. That is just a basic summary of how to solve two-step equations. Thanks.